Welcome to Study Loop.
Hello guys, so for this problem we're given a current carrying wire that bends 90 degrees like that in the presence of the magnetic field. Magnetic field is pointing out of the page, and so the question is we need to find a force that magnetic field exerts on this current carrying wire, and that force is given by the following equation. F equals I current and then the cross product of the distance of the length of the wire and the magnetic field. So because the wire magnetic field is always perpendicular to the wire, the cross product simply equals to I L B. So first, let's find out the direction of the force. To do that, we can use the right hand rule, and if you apply right hand rule, you'll see that the force acting on this part of the wire is pointing downward, and the force that acts on this part of the wire also is pointing downward. Now, uh, the force that acts on this part of the wire is pointing to the right if you apply right hand rule. So before we move on, let's select our coordinate system, and I will uh, point x-axis to the right and y-axis up. And first, let's calculate the force acting on this part of the wire. It's going to be on the x-axis, so Fx equals 4.5 amps times 0.3 meters. That's the length of this part, and times the magnetic field, 0.24, right, which equals to 0.324 newtons. Now the force that are depicted by the red arrows here acting on these parts of the wire can be thought as the force acting on the whole wire of the length of 60 centimeters. Therefore, it's simply Fx times 2, right? So it equals to 0.648 newtons, and it is negative because it's pointing downward opposite the y-axis. Now, so we have x component of the force pointing in this direction, and the y component of the force pointing downward. And what we need to find a magnitude of the force, which is this. So we need to find this total force, which is represented as this vector, right? This is our total force acting on the wire, and the magnitude of this force is simply square root Fx squared plus Fy squared, which equals to 0.725 newtons, right? And in order to find the angle that will describe this vector, angle phi equals to arctangent is 1 of Fy divided by Fx, and this equals to minus 63.4 degrees. That's it.